Engineering. I'm Alan. In today's video we start to make a thread dial gauge for the Boxford metric lathe. The lead screw on the metric lathe is 3mm pitch, and the original Boxford thread dial gauge had two gears, one with 20 teeth and one with 21 teeth. So we start off by making the body of the gauge. It's just an aluminium bar with a bush and a recess on this end and a bush and a recess on the other end. To go with the body, we have the shaft that goes through. The shaft is steel. It has an 8mm square on each end, a 6mm thread and a 6mm brass hand nut, and on this end there's a 4mm thread in the middle. So let's go into the workshop and see how we make it. So I can fit one of these small bushes, press that in, and it should be an 8mm bore. So I want a 10mm diameter, 12mm deep. I've just pressed that bush in and reamed it out to 8mm. So now I'll do the other end. What I'll do now is put that further back in the chuck. Okay, I've just set it up in the chuck and it's running out about 3 or 4 tenths. Each division's a tenth of a thou. Now I'll face this end off and prepare this end for another bush. This is the top of the thread dial. This one my brother printed out yesterday. We're still developing it. It has a square hole on the back. It's 15mm diameter by 5mm length. So what I need to do is bore a hole in here about 15.5mm diameter, 5mm deep, and then fit the second bush in this end. These are adjustable bore gauge. All it is 2 halves of a sphere, and when you tighten the end up it pulls the cone into the sphere, opens it out so it locks in the bore, and then you can measure the sphere to see what size bore you have. And you can see it grips the bore. The bore is about 10.5 I'll just open the bore up at the end and go in about a couple of mil. It's just starting to go in. I've made the diameter 0.1 mil bigger at the beginning, so that's a tap in fit, so I'll tap that in and then I can machine the end off. I've got a punch that the bearing fits onto, and I'll just place it in. It goes into the bore so it's lined up. All I need to do is tap the end. You can just see it's protruding, which is what I want. So now when this dial goes in, it's touching the end of the bronze bush and not the aluminium face. So what I need to do now is just turn the bronze bush just to face it off, but still leave it proud of the aluminium. You can see there the bronze bush, the face is square. That leaves a slight gap here, so I know that this is not rubbing on the aluminium surface. All I need to do is ream the bronze bush out to 8 mil. This end now is finished except for taking off the sharp edges. So you've got the brush face sticking above the aluminium. That makes the dial just sit proud of the aluminium, so it's not rubbing on anything other than the bore. I'll just put a temporary brass rod through with a square on the end. So this is how it works. The gear will be on this end, and this will drive that round so you can see where the lead screw is. Okay, so we're moving on to making the spindle for the thread dial indicator, and what I've done here is on the headstock I fitted number 3 Morse taper centre. I fitted my driving plate with a driving pin on the end there. On this end, on the tailstock, I have a revolving centre. This one revolves with the head, so these are known as live centres. If this was a centre that didn't have a revolving, it would be a dead centre. So because both centres are revolving, I don't need to put any oil or grease on the spindle between. This is the bar that I'm machining. It's about 9mm, I want it to 8. In this end I've just put a centre with the centre drill. I have drilled and tapped this end 4mm. The other end I've just put the centre and the driving dog. So that fits on there. Wind the centre in, move it round till it hits the driving peg, lock that up. So now what should happen, when the head turns, this will all turn with the head, this will rotate and all this will stay still. So let's just show you that. So now what I'll do is just put a cut on. Let's measure the diameter at this end. The diameter is 0.365, 66.5, and here it's 0.3699. 3/3 taper in this. This end is 0.364 and this end 0.367. So it's bigger on this end for some reason than that end. I could pull my tailstock over a fraction to sort that out, so it needs to come over about 3 thou. I've moved my tailstock over. I've just taken a cut. Let's have a look what this is. 50, just over 54. 0.354. This end 0.3545. I've changed it from 2 thou taper down to a couple of tenths, so that's okay. To adjust the tailstock, I've clamped a magnetic base onto the bed, put a dial indicator touching the side of the tailstock, and then you adjust this grub screw here and one on the other side to move the tailstock to the back or to the front. Remember to take the clamp off the tailstock because that would still hold it in position. So as you turn this grub screw, it will move the tailstock towards you, but you must undo the back one a corresponding amount. When you're finished, lock the tailstock back in position, machine the bar again and check that the tape has been removed. So what you're doing is moving the centre left or right depending on the difference in the error. So if you wanted it to be bigger on this end, you move it away from the tool. If you want it to be smaller on this end, you move it towards the tool. So now I'll see, I think the middle should be about the same, in case it's the middle's just under 5, so there's a bit of a bow in the, I suppose. As the tool pressure pushes the bar in the centre, it moves it away. It's a thou each end up and 2 thou in the middle. So I'll carry on polishing. I've just finished polishing up the spindle so that it will fit the body of the thread dial. And there's the bushes. And that just fits in there nicely. Okay, I've set my milling machine up. I've got ER32 collet in a square block. I'm just coming in now over the top to set my cutter to the right height, and then I'll be ready for machining. So now I turn it round, the other side. Okay, that's the square we did on the milling machine on the end. I've cut it to length and put another square on this end, and now I'm about to turn the end down to 6mm and put the thread on that. So on this end you have 6mm square, 6mm thread, and on the other end 6mm square, 4mm thread in the end. So that's finished. So we have the gear, plastic gear there, and this just holds the gear in position. So you can change from one gear to another by unscrewing the nut, taking the gear off, putting another gear on, putting the nut back on. And all I need to do is machine half of this away so the gear's exposed and will touch from the side the lead screw. Oh well, that's it for today. Hope that was interesting. Hope you enjoyed this, and we'll continue it next week in part 2.